guys, in this video tutorial I would like to explain uh, Venn diagrams, which is a part of the probability and statistic. And probability and statistic, this diagram is used to explain different probability questions where we express the sample space by a rectangle and the events which occurred in that sample space are normally represented by circles. So let's move to the formal lecture. And this diagram was first presented by J. Venn in 1835 to 1838. And in this diagram, normally it is represented by, you can see that by a rectangle, and the event in this diagram is represented by circles. So this is one of the easiest way to express the probability problems, and this can help to make it easy in the solution. So let's move towards some example that how we can develop a Venn diagram for different problems. This is another example, but we will do this from our problems so that we can explain this. I have these problems, so you can see that the first problem is the event x and y are mutually exclusive. Suppose probability of x is equal to 0.5 and probability of y is equal to 0. Probability of x is equal to 0.05 and probability of y is equal to 0.02. Draw a Venn diagram to interpret these probabilities. So you can see that. Okay, so now we have two events, that is x. So the probability of x is equal to 0.05 and the probability of y is equal to 0.05, 0.02. Probability of y is equal to 0.02. Now I need to draw a Venn diagram for two events to interpret these probabilities. So we already know that a Venn diagram is normally represented by a rectangle, and the event inside that, the events of the problem is represented by circle inside that rectangle. I will show this. You can search any standard book of probability and statistics. You will see Venn diagram. I will just show one of the book. This book, you can see the title. This is Probability and Statistics for Engineer and Scientist. So this is one book. You can just Google Venn diagram and you will see. Just not Google, just search Venn diagram. I am writing Venn, and you will see there is. You can see this. These are this is mentioned in this. The relationship between events and the corresponding sample space can be illustrated graphically by means of Venn diagram. In a Venn diagram, we let the sample space be a rectangle and represent any events by circle drawn inside the rectangle. So this is the same definition which I did already. The sample space is represented by a rectangle and the events by circle drawn inside the rectangle. So let's move to the problem and see how. So these are the two events. So now I would like to draw a Venn diagram for this problem, and that's of course the sample space I will draw like this by a rectangle, and the two events, as it is mentioned in the problem that these events are mutually exclusive, so there is no common point. Therefore I will write like this. This is suppose one event and this is suppose other event. Suppose this is event x, this is y, and you can mention their probabilities that 0.05 is the probability and this is 0.0. So this is one diagram for problem 1. Problem 1. Now let's move to problem 2. I have different problems so you can see. Problem 2, the probabilities of event A and B are 0.20 and 0.30 respectively. The probability that both A and B occur is 0.15. Draw a Venn diagram to interpret these probabilities. So, problem 2. Problem 2. In problem 2, there are two events A and B. Probability of A is equal to this one. I will write this. And probability of B is equal to this one. And probability of A intersection B is equal to this one. This I remember is 0.15, and the other two are 0.20 and 0.30. 0.20 and 0.30. So now I need to draw a Venn diagram for this problem to interpret these probabilities. So I need again by definition that I can draw a rectangle. There are two events A and B, so I can draw one event. This is suppose event A and the other is event B, but remember that there is common point that is represented by probability of A intersection B, which the problem mentioned that the probability of occurring both event is this one. So we need to have common point in this case. This is B, event B, this is event A, and this is A intersection B. And you know that the probability of this is 0.30, the probability of A is 0.20, and the probability of A intersection B is 0.15. So this is the common point. Okay, so this is the interpretation for this problem. Now I'll move to problem 3. Let's see what is the statement of problem 3. Problem 3 says that probability of x is equal to 0.55 and probability of y is 0.35. Assume the probability that they both occur is 0.25 as 0.20. Interpret this probability using Venn diagram. Okay, so now let's see, we have two events again. We have two events in this problem, that is x and y. Probability of x is equal to 0.55. Probability of y is equal to 0.35. Probability of x and y is equal to, I think that is 0.20. Yes, this is 0.20. 0.20. So now I need to draw a diagram. So by definition, I can draw a rectangle that is for sample space, and then I can draw two events by drawing circle. So this is one is event x. So this is suppose event x, and now event y. But remember that there should be common point because the probability is probability of x intersection y is 0.20. So this should be look like this. So this is event y, event x, and this is x intersection y. So you can interpret this, you can write the probabilities also, and this is the common point, which is x intersection y, and the probability of this portion is 0.20. Now, problem 4, you can solve other problem. I will solve these 4 problems by interpreting Venn diagram. So, problem 4 is interesting. A survey of top executive related revealed that 35% of them regularly read Time magazine, 20% read Newsweek, and 40% read US News and World Report. This means that we have 3 events in this problem. 10% read both Times and US News and World Report. Interpret this problem using a Venn diagram. Okay, this is a bit lengthy problem. I mean that there are 3 events, so we need to be careful. Time magazine. So first we need to write these events. Like suppose I will say I will denote Time magazine by T, Newsweek by N, and US News and World Report by N. Not N because Newsweek is by N, so we will write World Report, News and World Report by W. Okay, Time magazine, Newsweek. Okay, we have 3 ones in this problem. We have 3 events and this problem. These events are A, suppose, okay, these are Time magazine. Suppose T denote Time magazine. Suppose N denote Newsweek, and suppose I just want to see US News and World Report. Suppose W denote US News and World Report. So these are the 3 events we defined already them. Now, you can see I can start a Venn diagram now. Not should not be with the W. Venn diagram. So of course I can start with the rectangle. Okay, so now there are 3 events which is T, N, and W. Now again look at the problem very carefully. What is the statement? 35% read Time magazine. So you can write the probability. You can write on the side probability of Time magazine is 0.30. 35% mean 35%, so you can convert this to probability divided by 100, that will make it's 0.35, 0.35, yes, 20% music and 40% the last one. So this means that this probability is 0.35, probability of Newsweek is 0.20, and probability of W, which denote US News and World Report, that is equal to 0.40. So there is another thing which is mentioned in the statement. So let okay. 10% read both Time magazine and US News and World Report. So this is the intersection part. Times, Time magazine and US News World Report. So this means that we can write probability of Time magazine and World US News and World Report, that is equal to 0.10. So now we have the summary of this problem, so you can develop a Venn diagram. So we already drawn the sample space now has three events. So this means that the first one, Time magazine and W, this have some common point. And US Newsweek has no intersection with the other. So you can draw Newsweek on the side. There is no common point in this Newsweek. So this should be a circle. And now the other two, that is T. So this is Newsweek. Now T and W. So this is T and this is W. And this is the common point, that is T intersection W. This is the common point. So this make really easy to understand the problem of probability and statistics, particularly the problem of probability, because you can interpret this very easy now. Uh, Newsix has no common point, and Time magazine and News and World Report has a common point between them. That is denoted by T intersection W. So this is all about Venn diagram. We will proceed the problems, solving the problem with different laws of probability in the next lecture. So thank you very much for listening, and see you in the next lecture. Ciao.